Hello, this is Blake McHugh. I'm attempting Chapter 4 Video Reassessment. The problem I've chosen is two objects are suspended on a pulley. The mass of object 1 is 1 kilogram, and the mass of object 2 is 10 kilograms. And we're trying to find the acceleration of object 2. Alright, right here you can see the first thing I did was I drew a picture of our problem, and we have object 1 right here, as well as a free body diagram, object 2 and a free body diagram. Okay, on object 1 we only have two forces acting on it. That's going to be force tension and our force of gravity. Right here you can see our force of tension is going to be slightly larger than our force of gravity. And over here it's just the opposite. Our force of tension is going to be lesser than our force of gravity. Alright, so first thing we do after our free body diagram is we write down what we know. We know on both sides the sum of all forces is equal to mass times acceleration. And we know on object 2 the sum of all forces is equal to mass times gravity minus the force of tension. And that's going to be because our mass times gravity is greater than our force of tension. And on object 1, our sum of all forces is the force of tension minus our force of gravity, so just the opposite there. Alright, because we have the sum of all forces equal to on both sides, we know that the sum of all forces for object 1 is mass times acceleration is equal to force of tension minus mass times gravity. And object 2, mass times gravity is equal to, mass times acceleration is equal to mass times gravity minus force of tension. So we just plug in what we know. And we got 1 kilogram times acceleration equals force of tension minus 1 kilogram times 9.8 meters per second squared, force of gravity. The problem is we have two unknowns. We have force of tension and acceleration. And that goes for the same on the other side. We have acceleration unknown and we have force of tension unknown. So first thing we do is we solve for A. We do that, we multiply our 10 kilograms times 9.8 meters per second squared, which that's going to give us 98 newtons. We still keep our minus force tension, and then we divide by 10 kilograms right here. And that gives us acceleration. Over here, we do the exact same thing, but we divide by 1 kilogram. Now we could potentially take this out and make this newtons, meters per second squared again, but we don't want to do that because that's going to mess with our units. Alright, so once we got acceleration on both sides, we can set the problem equal to each other. And you can see right here, first thing I did was I multiplied times 1 kilogram. And basically all that did on this side, it canceled out our 1 kilogram on that side. And on this side, it canceled out our bottom kilogram unit. So now we just got 10 with no units. We multiply that 10 to the other side, we get 10 times the force of tension minus 98 newtons, because we multiplied 10 times the 9.8 newtons. And that's equal to 98 newtons minus force of tension. Well, we add force of tension right here to cancel that out. Add force of tension right here to give us 11 times force of tension. And then we add 98 newtons on this side to the 98 newtons on that side. We're left at 11 times force of tension is equal to 196 newtons. And we get force of tension is equal to 17.8. And that unit is going to be newtons. So then we know we're looking for acceleration on object 2, which that's our 10 kilogram object. And we take our same equation that we already know, mass times acceleration is equal to mass times gravity minus force of tension. And then we solve for acceleration. We just do that by dividing both sides by the mass. And right here, we could cancel out, but that's going to leave us, well, again, with messed up units, that would leave us subtracting meters per second squared minus newtons. So I don't want to do that. So go down to here and just plug in our numbers. We got 10 kilograms times 9.8 meters per second minus our 17.8 newtons, which is our force tension, divided by 10 kilograms. Subtract down. Again, we got newtons minus newtons now. And then we divide that by kilograms. So a newton divided by a kilogram is going to be a meter per second squared. But to plug this into the calculator, you get acceleration is equal to 8.02 meters per second squared. And that's going to be the answer we're looking for.